Here we have a released free response question for AP Chemistry that regards energy. We have a sample of solid uranium oxide in a 1.5 liter flask, and we're adding chlorine to it. We then also heat it up very hot. The reaction is subject to equilibrium, and it produces some UO2, Cl2, as well as some oxygen gas. They give you the equilibrium constant with regards to pressure. Note that they do omit the solid here since it's not part of the equilibrium. The coefficients become exponents. Wonderful. I'm going to read all these questions, maybe provide little hints for each, and then we'll answer them all one at a time. They want the partial pressure of oxygen at that temperature. Well, they do give you the partial pressure of UO2Cl2, so there is a ratio there. They want the value of the equilibrium constant for the system at that temperature. Well, between this and the one you calculated, you may have them all. They would like the Gibbs free energy change for that reaction. There's a formula for that, and perhaps it's no more than just simply plugging in. They want to know if the entropy change is positive, negative, or zero. Note that we have a solid and 3 moles of gas forming 4 moles of gas. State whether the enthalpy change for the reaction is positive, negative, or zero. They are leading you down the garden path. You've determined the value of positive or negative for your free energy. You've determined positive or negative the value for your entropy. We should be able to get it for the enthalpy. Finally, after a little while, they add up some more oxygen. Which way does the equilibrium shift? Note that oxygen is a product. If you've been working your way through AP Chemistry, each one of those little hints probably said, oh yeah. So let's take a look at each answer. And somewhere, there it is. Okay, so as before, we noted that there's a 3-to-1 ratio for UO2Cl2 and oxygen. If they give you the UO2Cl2 at equilibrium, for every 3 of those form, only 1 of those form. So the partial pressure will be 1/3 that of UO2Cl2. That is part A. For part B, we have everything right here. We plug in all those 3 numbers, punch them in, and we get an insanely low number for the equilibrium constant. In the next question, they would like the Gibbs free energy change, and we do have everything we need for the minus RT natural log of K formula. There's our energy version of R, that's joules per Kelvin mole. Here's our values in Kelvin, here and here, times the natural log of K, which we calculated there, and that's the free energy change, and notice that it's positive, non-spontaneous. Finally, we're only at D, state whether the entropy change will be positive, negative, or zero. Well, we are taking 4 moles and turning them into 4 moles, but on the product side, they're all gas. On the reactant side, one of them is a solid. Things seem more random on the product side since it's all gases. Therefore, things are getting more random. That's a positive entropy change. How about the enthalpy change? Well, for that, we do have delta G is positive and delta S is positive. By virtue of the way these things go, though, we're subtracting out delta S. That doesn't help make it positive. That'll make it more negative. The only way it can be positive overall is if delta H is positive. And finally, the last question, they add a little bit of oxygen. Which way will the reactant shift? Well, oxygen is a product, and Le Chatelier's principle tells us adding product will shift things back towards the reactant side, so it will go to the left. This is an AP Chemistry free response question about energy.